Good morning, children. Uh, First of all, I would like to um, tell you that earlier I gave, I think, 7 questions of homework. Okay. You'll be getting today's homework also, so that might take a long time. So it's enough if you do 2, 5, and 9. Numericals 2, 5, and 9. Okay. The others are a repetition of this type. So you just do 2, 5, 9. Okay. And that is enough. I think 3, 8, and 10 we did in the Zoom class yesterday. So for homework you do 2, 5, and 9. That's enough. Okay. And the rest of the numericals we'll be doing in next week's Zoom class. Okay, so I'm keeping these numericals to be done in Zoom class. Now we go to the next chapter, but in this A part quite a lot is cut. Okay, quite a lot of portion is cut. So actually nothing is there except one small portion. Okay, so this is cut, and then this is cut. Okay, now only this is there. Okay, so I name it chapter 9b. Okay, so I told you this C part of 8 we took it as chapter 9a, and this is your chapter 9b. Okay, power distribution to a house, we'll see that later. Then this is not there, house wiring you can cut off, then all this is cut off. Okay, and then this is cut. Connection in parallel is there. Yeah, advantages of connecting appliances in parallel, this also is there. Sorry, you can erase this off. So only, okay, so this is there, so this is to be cut off. Okay, so in this part only one part is there, that also I'll be doing it towards the end. I'm going to start now with chapter 9b, some essential components of house wiring system. Okay, some essential components of house wiring system. Okay, so these are some of the things that are part of a household electricity, we can call it. What are the components that we are going to see, or the components that we are going to see are: first is fuse, second we're going to see about switch. Okay, so fuse, then switch, then we have earthing. Okay, earthing, that is earth wire is there, and why do they do that and all that. And then about 3-pin plugs and sockets. Okay, 3-pin plug and socket, and then we have something called color coding. Okay, so mainly these are the these are the 4 components which are part of electricity. Okay, you know, there is, you would have heard about fuse. I think this phrase fuse uduga is a very common phrase, right? Fuse has blown off. So fuse is one of, it's a safety device. Switch, you know, it's an on-off device. Earthing is also a safety device. 3-pin plug and socket, you know, it's a kind of point through which you get voltage as the output, and you connect your appliance to that. Okay, so we'll start first with fuse. So you all have heard about fuse. Yeah, at least the term that I said, I'm sure you would have heard. So the definition of fuse says it is a safety device. Okay, so this is the definition. An electric fuse is a safety device which is used to limit the current in an electric circuit. It is used to limit the current in an electric circuit. Now, before going into that, I need to teach you some basics. Now, suppose you take this as an appliance. Appliance means any, like maybe it's a room heater, water heater, or whatever it is. Basically, it will have high resistance coil. Okay, and the wire that is coming inside, it will have 3 wires: live, neutral, and earth. Outside it looks like a single wire. If you cut it and see, there will be 3 strands of wire: live, neutral, and earth. I hope you are familiar with this. So usually the appliance, okay, one wire of the appliance will be connected to the live wire and current enters through this. Okay, so this is the wire that is coming from the pole near your house, the electricity pole that supplies current to your house. So from there the line will come, so that wire will be connected to one end of this appliance, and then the other end of the appliance will be connected to neutral. And then the body of the appliance, okay, earth let's not see now, okay, earthing we'll talk later. Let's now talk about only live and neutral. So basically there are two important wires. One is live, through which current enters, and then the neutral, through which current comes out. You know that for current to flow in any path, there has to be a closed path, in the sense there should not be a gap anywhere. There should be a complete path, and then only it will start flowing. If anywhere there is a open here or there, then the current will not start flowing. Okay, so this is the wire through which current enters, and this is the wire through which current goes out, and this forms a complete circuit. Now what will happen is, every appliance, suppose you have a water heater, it can only there is something called safe current. It will have a power rating. Based on the power rating, you can calculate safe current. Now what does the safe current mean? Whenever current enters, the current that is coming here is going to cross 5 ampere, then this is going to melt off. Okay, this will melt off, and then the whole appliance might get damaged. So always the current that is entering, if it is low voltage, it's still fine. It will not work to its full capacity, but nothing dangerous will happen. But if it crosses 5 amps, then it is really dangerous. Okay, and the appliance can, the whole appliance can be wasted. Okay, it will get damaged, and then you cannot use it again, or you might have to repair this coil, which will be very expensive. Okay, all these things can happen. Now, and as I told you, in India we have lot of fluctuations. Though we say 220 volt is the volt that comes in our through our plug points, usually it's 180, 200 or 210. Very rarely 220 comes, and once in a while it even goes to 240 or 250. And this, when it goes to this much, it's very, very dangerous. Okay, as the voltage increases, current also will increase. Now suppose the voltage, the input voltage that is coming here has suddenly increased, and therefore the current is also increased. So only suppose 6 ampere current is coming. Okay, 6 ampere current is one day coming. Now as I told you, this appliance can withstand current till 5 ampere. Okay, so if 6 ampere current is going to come inside, this will melt off. So what they do, before the current goes into the appliance, they keep a fuse here. They keep a fuse here. Now basically what it has is, it's a wire. Okay, these are the two terminals, wire coming inside and then it goes out, live wire, and this wire is a different wire called a fuse wire. The fuse has a special wire called fuse wire, and this wire has two special characteristics. One is, now this wire is copper, you all know that, no? Conductor, this is copper. Okay, but fuse wire is a special wire which has a low melting point when compared to copper or aluminium. Okay, high resistance, low melting point. Fuse wire, when you think of fuse wire, you should remember these characteristics. It should be of high resistance and low melting point. So what happens by chance, and fuse wires are of different thickness. Okay, so there is a fuse wire which will not melt till 5 ampere. When the current crosses 5 ampere, then it will melt. So such a kind of fuse wire they'll put here. So what will happen is, till 5 ampere nothing will happen. It will keep conducting the current. Now one day when the current came as 6 ampere, this gets heated up so much, and so this will get cut. So your fuse wire gets cut like this, and now current cannot flow because there is a open here. Current cannot flow through this, and that way your appliance is protected from getting damaged. Only your fuse wire would have got melted. All that you have to do is change the fuse wire, put a new wire, then it will start working. That's the reason why, if any of your appliance is not working, suppose your refrigerator is not working and you call the mechanic, the first thing he does is he checks the fuse, because suddenly anytime some high current would have come and that would have melted the fuse. Okay, and fuse is there in almost every appliance. Your inverter will have a fuse, even refrigerator, television, everything has a fuse. Even an extension board, okay, an extension board which has 3-4 plug points on it, even that has a fuse. So fuse is for a safety purpose, and it should be connected before the appliance, so that whenever high current goes, it will melt and cut off the current. So when it cuts off, automatically current will stop flowing. It's like a gate. Okay, when it opens, current will not flow, and so this appliance will be saved. So you can just open the fuse, change this wire, and again it will start working. Hope you understood about fuse. So definition, you can note it down. It's a safety device which is used to limit the current in an electric circuit. Limit current in an electric circuit. Then come to the next thing, material of fuse. Okay, composition I've written. Fuse is made of alloy of tin and lead. Alloy of tin and lead, and it has two important characteristics. One is low melting point, high specific resistance. Low melting point, high specific resistance. Now why is that so important? When compared to this copper, this is copper wire and this is fuse wire. Now fuse wire has a low melting point when compared to copper. So when the current crosses that limit, the first one to melt will be the fuse wire. This copper wire will not melt because its melting point is little higher. So purposely they place this fuse wire which has a low melting point, so that it will, the moment the current crosses the limit, it will quickly melt and break the circuit. Okay, so high resistance means generally, as I told you the other day, all the heating appliances work based on this heating effect of current. Okay, because of the resistance, okay, it will get heated up, and the amount of heat energy is given by I squared RT. So if you make this resistance high, then it gets heated up also much faster, and that's why its melting point will be it will melt quickly when compared to copper. We don't want this copper wire to melt. Okay, if this melts, then the whole thing has to be changed. Now fuse is a thing that I can fix it, only take it out, fix it back. Whereas if it is a if this copper wire melts, then I have to change the whole system. That might be too difficult. Okay, this was the fuse arrangement that we had few years back. Even now, some very old connections, like I've seen this near transformer. You can see these big fuses made of porcelain. Okay, it will be like clay. Okay, so this was the fuse that we used to have before. Okay, some years back. Even now in the older circuits we have, but these days it is replaced by something called cartridge type fuse. Okay, this is there in every appliance. I took this out of a extension board. Okay, so it was just screwed inside. I just took it out. Okay, now can you see a thin wire inside? There is a thin wire inside. So when current crosses, this wire will melt and it will get cut. Therefore the current will not go through. Normally through live wire will be connected here and current will be going. it will be sending the current, but when it crosses the limit it will melt, so current cannot flow and your appliance is saved. So the first thing the technician will do is he'll take it out and he'll see if it is cut, then he'll have to just change it. You can in this case you can replace it. These kind of cases they will just change the fuse wire. The wire will be there between two screws, here two screws. If it is got melted, then they will just put another fuse wire, proper one, and then put it back in the holder and it will function. Cartridge type, this is very cheap, you can just replace it. You can get a new cartridge type and put that. Okay, so that is how it works. Okay, now explain how fuse works. I already explained you, just mark the points. Okay, there are lots of information here. Okay, so give reason why a copper or aluminum wire is unsuitable for use as fuse wire. Now why should I use a special wire? I said it's an alloy of tin and lead. Is it compulsory to use this? Can't I use a copper wire or a aluminum wire itself, the one I use? No, you cannot use this because it has high melting point and then it has low resistance. Okay, means low resistance means it doesn't get heated up much. It doesn't get heated up much, then it's not going to melt. Okay, and it will be quite thicker. This fuse wire, if you see, it will be very thin. Okay, the strands will be very thin, whereas the copper wire that we have might be thicker when compared to that fuse wire. Now, more the thickness, you know this also, resistance is inversely proportional to area of cross section. So if thickness is more, resistance will be less. So again, a copper wire, because it is thicker, its resistance will be less. Basically its resistance is less. You know, copper is a good conductor, so heating, it won't get quickly heated and melted. Okay, so that's the reason. So just underline these two things. They have high melting point. We're talking about copper or aluminum. It's unsuitable for fuse wire. Why? They have high melting point. Second, since it is very thick, it will not melt even if current exceeds the safe limit. These are the two reasons why we should not use copper or aluminum as fuse wire. Then we have explain how fuse works. Okay, the first point, when current in the circuit exceeds the specified value due to any reason, the temperature of the fuse wire rises to the extent that it melts. As a result, a gap is produced and the circuit breaks. Now, current does not flow through the live wire and the appliance is saved. It will not work. Okay, immediately it will just get cut off. Okay, it will not work, but it's okay. It is saved from getting blown off or getting melted. Okay, it is saved. So after removing the fault in the circuit, a new fuse wire of the same current rating is connected to complete the circuit again. Okay, so this is how the fuse wire will be there. If it melts, this will be broken, so the path for the current will be broken and current stops flowing. So, and as I told you, there are different fuse wires of different rating. I can't put the same fuse wire for everything. Okay, so 1 ampere, 2 ampere, 5 ampere, 10 ampere, these are the different fuse wires. Okay, this is the one I showed you, cartridge type fuse. There is a glass case, there is a fuse wire. This is soldered to these metal caps. Okay, it's soldered means permanently fixed. That's why you can't remove this wire alone. You have to replace the whole thing. And it's quite cheap, so it is not a issue. Okay, then the next information that you should know is, why should the fuse wire be connected in live wire? Fuse is always connected in the live wire. What will happen if the fuse is connected in the neutral wire? Okay, usually fuse should be connected in the live wire. Now you should know what will happen if you connect it in neutral wire. So as usual, if its current rating is 5 amp and one day 6 ampere current is coming, so a high current comes and this fuse wire is melt, because this fuse wire can withstand only current till 5 ampere. So in this path there will be a open circuit, in the sense So current enters through this and comes out through this, but there is a opening. So don't say, ma'am, current here, the path is open, closed, so can the current flow even though the fuse melts? Will the current flow? No, current will not flow, because current is very smart. It starts from here and it will flow only if the entire path is closed. If it sees open anywhere, okay, if it sees an open anywhere, see, when this fuse wire melts, you're going to have a open like this, right? So it will not start moving from here at all. So till this point, from here to here, the path should be complete. Anywhere in between, if there is an open, so if the fuse wire is kept in a neutral wire, fuse wire will melt, current will not flow, in the sense current will stop flowing. So that is okay. But the problem is, this live wire is still connected to 220 volt. Now what happens? You will think, because this fuse wire will cut, you are every time, means you switch it on but this appliance is not working, so you call the electrician and he opens the circuit, and what will happen, because this live wire is directly connected to the fuse wire, when he is trying to touch this wire and do some repair, he will get a shock and it will be very, very dangerous, because this live wire is still connected to this part. So if you give a path for it to flow, if a man touches it, then the current has a path to flow, it will flow through him and the person will get a shock. So that is why it should be always connected in. Okay, so here it should be connected that to before the appliance. Two things, it should be connected before the appliance, so that whenever current rate exceeds, it might melt and break the circuit, and so no current will flow. But if it is connected in the neutral wire, what will happen? Current will stop flowing, but appliance still remains connected to the, okay, the answer will be appliance still remains connected to the high potential point of the supply. So if a person touches, he gets an electric shock because he comes in direct contact through the mains, through the live wire. Thus it is highly unsafe to use fuse in a neutral wire. Then comes the next topic, current rating. Now each appliance will have a different current rating. Okay, now you know, we studied in the last chapter something about safe current. So every appliance is designed with a power rating, in the sense it will consume this much power when you give this much of voltage. Now with this information, I can calculate something called safe current. So safe current I will be P by V. P is equal to VI. So I is equal to P by V. So 1200 upon 220. I think it will come up to 5.5 ampere. So this appliance, for this appliance, they will put a fuse wire of current rating 5.5 ampere. That means this fuse wire will not melt till 5.5 ampere. Whenever the current crosses 5.5 ampere, it will melt and it will open the circuit, in the sense current will no more be able to flow through the appliance. Okay, now suppose there's another appliance whose power rating is say 2000, it's a geyser. Suppose imagine there's a geyser whose power rating is 2400 watt and 220 volt. Now what will be its safe current? The safe current will be 2400 upon 220. It will come out to be 11.9 something, or approximately I can take 12 ampere. So if it is a geyser, okay, suppose if the appliance is a geyser whose power rating is this much, then my the fuse wire that I'm putting should have a current rating of 12 ampere. So I should put a fuse wire. Basically what will be the difference between this and this? This will be a thinner wire. Okay, fuse wire of current rating 5.5 will be thinner, of 12 ampere will be little thicker, so that it will not melt so easily. Now what will happen if I put this fuse wire here? What will happen if I just, in this geyser, it needs 12 ampere, but I'm putting a 5.5 ampere fuse wire. What will happen? Every time when you switch it on, the current is going to, because it needs 12 ampere, so current is definitely going to be more than 5.5 and the fuse will keep getting cut. Every time you switch it on, fuse will blow off because you have put a 5.5 fuse. So you should only put a 12 ampere fuse, then only it will not melt till it crosses 12 ampere. Till 12 ampere it will not melt. Okay, hope you understood. So current rating is one important information. It can be obtained from the formula power upon voltage. Now what information does current rating give? A thick fuse wire, higher current rating, is used for heavy current consuming, and a thin fuse, current rating of main fuse. Okay, okay, fine. Now they have given a table which gives some of the common appliances that we use and their current rating, the current rating of the fuse. See, electric oven and all needs a 15 amp fuse wire. Kettle means 10 amp. That depends on their power rating. Okay, so what information does current rating give? It tells you the maximum current that can be withstood by that fuse wire, beyond which it will start melting. Now the question can be, what do you mean by the statement the current rating of a wire is 5 ampere? Okay, what will you say? Whenever current crosses 5 ampere, the fuse wire will melt. That is the meaning of current rating of a fuse wire is 5 ampere. Then come to the last part, MCB. So nowadays fuse is replaced by MCB. Okay, so I showed you cartridge type fuse. Those are there in appliances, like separate appliances like inverter or refrigerator or extension boards and all they have. But every room, okay, every room you have a switchboard in every room. Earlier they used to have a fuse, this kind of fuse in every room. Okay, and when the high current enters that room, that fuse will melt and none of this appliance connected in this room will work. Okay, so you have to change this fuse and everything will be okay. But instead of this, now we have MCB. It's full form, miniature circuit breaker. Basically it's a set of switches. You all would have seen this near the electric meter in your house. There will be this MCB. So it will be basically different switches to different room. Room number 1, one switch will go. Room 2, one switch. Room 3 is one switch. Now anytime high current goes to this room, this switch will automatically switch off. And all that you have to do is, the switch would have come down. All that you have to do is lift it up, switch it on again. When suddenly high current comes, automatically it will switch off. All that you have to do is put the switch back on and it will start working. So the recent development in place of fuse is, nowadays instead of fuse, MCB, miniature circuit breaker, is used for each individual circuit. Okay, so if a heavy current flows, MCB switch falls down and then very short time. Okay, now why is MCB? Advantages of MCB over ordinary fuse. One is it avoids inconvenience of connecting a new fuse wire. Now the problem with this kind of fuse is, every time when the fuse wire goes off, they have to remove this, open the screw, take out this broken wire, then fix a new wire and then put it. It will take some time. But in this case, all that you have to do is, as I told you, the switch would have automatically got off. You have to just put it up, means keep it on. It will start working. Second one, it is much safer due to its quick response. It responds very quickly. This at least takes few seconds to melt, but this will be very, they say its response time is 25 milliseconds. So quickly it will respond and it is much safer. Okay children, so I am stopping with this. We'll start the next class. I'll be sending some questions. Please write the answers and send it back to me. Thank you children.